Hello everyone! Today we're diving into an exciting development in the field of machine translation and neural network approach that's changing the game. We'll be looking at a groundbreaking paper that introduces a new model called RNNsearch, which addresses some key limitations of previous neural machine translation systems. The problem with traditional neural machine translation. Let's start by understanding the challenge. Traditional neural machine translation models, known as encoder-decoder systems, have a significant limitation. They try to compress an entire input sentence into a fixed-length vector, from which the translation is then generated. This approach struggles with long sentences, often losing important information in the process. Introducing RNNsearch. Enter RNNsearch, a novel architecture designed to overcome this limitation. Instead of compressing the whole sentence, RNNsearch allows the model to automatically search for parts of the source sentence that are most relevant for predicting each word in the translation. This is achieved through a mechanism called soft alignment. How RNNsearch works. The model consists of two main components, an encoder and a decoder. The encoder is a bidirectional recurrent neural network, RNN, that reads the input sentence and creates a sequence of annotations. Each annotation contains information about the whole sentence, but with a focus on the words around its position. The decoder, another RNN, then generates the translation one word at a time. Here's where the magic happens. For each word it's about to generate, the decoder computes a context vector by weighting the annotations from the encoder. This weighting is based on their relevance to the current state of the decoder and the previous generated words. The alignment model. The weighting of annotations is done by an alignment model. This model learns to score how well the inputs around a certain position match the output at the current position. It's essentially learning which parts of the input sentence to pay attention to when generating each word of the translation. Advantages of RNNsearch. This approach has several benefits. 1. It can handle sentences of any length more effectively. 2. It doesn't lose information by compressing everything into a fixed-length vector. 3. It can focus on relevant parts of the input sentence for each word it generates. 4. The alignment between input and output words is learned as part of the overall translation task. Performance results. The researchers tested RNNsearch on English to French translation tasks. The results were impressive. RNNsearch outperformed the conventional encoder-decoder model, especially on longer sentences. It achieved performance comparable to state-of-the-art statistical machine translation systems. The model showed robustness to sentence length, maintaining good performance even on very long sentences. Qualitative analysis. One fascinating aspect of RNNsearch is that we can visualize the alignments it learns. The researchers found that these alignments often correspond well to our intuitions about translation. For example, the model correctly aligns noun-adjective pairs between English and French even though their order is typically reversed. Handling long sentences. Let's look at a concrete example. For the input, an admitting privilege is the right of a doctor to admit a patient to a hospital or a medical center to carry out a diagnosis or a procedure based on his status as a healthcare worker at a hospital. The conventional model struggled with the latter part of the sentence. RNNsearch, however, produced a much more accurate and complete translation. Implications and future directions. This work represents a significant step forward in neural machine translation. By allowing the model to focus on relevant parts of the input dynamically, it opens up new possibilities for handling complex, long-form text. The researchers suggest that this approach could be extended to other tasks beyond translation, potentially impacting various areas of natural language processing. The RNNsearch model demonstrates the power of attention mechanisms in neural networks. By allowing the model to learn what to focus on, we can achieve more flexible and powerful systems. As this technology continues to develop, we can look forward to more accurate and natural-sounding machine translations, bringing us closer to breaking down language barriers worldwide. That's all for today's video. If you found this interesting, don't forget to like and subscribe for more content on cutting-edge AI research. Thanks for watching.